Okay, confidence interval notes, talking about the z-test one prop. So a sociologist is studying the effect of having children within the first 2 years of marriage on the divorce rate. Using hospital birth records, she selects a random sample of 200 couples that had a child within the first 2 years of marriage. Following up on these couples, she finds that 80 couples are divorced within 5 years. So how do we find a 90% confidence interval for the proportion of all couples that had a child within the first 2 years of marriage and are divorced within 5 years? So can we actually perform a 90% confidence interval? Okay, if we think about our formulas, z-star, we need a standard deviation, a mean. We don't have that, okay? So we don't have a mean, we don't have a standard deviation. Can I use the z interval, confidence interval? No, I cannot, okay? So I need a different test. So the one sample z interval for a population proportion, once we find the critical value, our confidence interval for the population proportion can be given by this formula. Again, as always, it is your statistic, which we call p hat, plus or minus your critical value, which we call z star, again, based on confidence level, and times the standard deviation, which for proportion is going to be big square root p hat times 1 minus p hat divided by n. Make sure that you can access this on your AP formula sheet, know where it's at. So yay, luckily we don't need to memorize. So to perform a one prop z interval, choose an SRS of size n from a large population that contains an unknown proportion p of successes. An approximate level C confidence interval can be given again by the formula. Where your Z star again is based on your confidence level, 90, 95, 99. And you can only use this interval when the number of successes and failures in the sample are both at least 10 and the population is at least 10 times as large as the sample. So again, you have to check your conditions for normalcy first. So again, you can utilize the formula in order to find your actual interval, or we can use the calculator trick. So the calculator trick, again, you're going to go to menu, statistics, confidence interval, and then you're going to go to one prop z interval. And just like with the z interval, again, if you're using calculator, here's how you need to show your work. You need to name the test one prop z. You need to put CI and everything the calculator asks for. Okay, your number of successes, your n equals, you could also call this x equal, n equal, ci equal, p hat. Make sure to label, don't just put numbers. Actually make sure to label the variables. So how do I know when to use? Problems will say proportion or use p hat. Okay, so you know it's a one prop proportion if it says the word proportion, or it actually gives a p hat. So let's look at an example. Again, back to the sociologist question, studying the effect of having children within the first 2 years of marriage. Using hospital birth rate, she selects a random sample of 200 couples that had a child within the first 2 years. Following up on these couples, she finds that 80 couples are divorced within 5 years. So how do we find a 90% confidence interval for the proportion that had a child within the first 2 years? Well, first, let's check your conditions. So successes, we have 80 is greater than 10, so that checks. Failures, 200 minus 80 is again a deed above 10, check. And the population of all marriages in the world definitely is greater than 10 times 200. So yes, our normal conditions are checked. We can show work by either using and writing the calculator work, one prop z interval, again found by menu, stats, confidence interval, one prop. or you can use the formula if you want to plug into the formula. Again, make sure that you're using plus and minus. We should get a C lower value and a C upper value. And end with a conclusion statement. We are 90% confident that the proportion of all couples that had a child within the first 2 years are divorced within 5 years lies in the interval 0.34 to 0.46. Okay, how do you know to come up with a sentence? Use the wording, finding 90% confidence interval for the proportion. So use the actual wording in the problem to figure out what comes after your confidence interval. But all three parts, conditions, show work with formula or calculator work written out, and conclusion statement. So a customer has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey. Before contacting the consultant, the company president wants some idea of the sample size that she will be required to pay for. One critical question is the degree of satisfaction with the company's customer service, measured on a 5-point scale. So the president wants to estimate the proportion of customers who are satisfied, that is, who choose either somewhat satisfied or very satisfied, two highest levels on the 5-point scale. She decides that she wants to estimate to be within 3% at a 95% confidence level. How large a sample is needed? So this is finding a sample size problem, finding a sample size. So if we look at margin of error equation for proportion, we have margin of error, ME, equals your Z statistic times big square root P hat times 1 minus P hat divided by N. So let's plug in what we know. We know that we are looking for a 95% confidence level, and that has a Z statistic of 1.96. We know that our margin of error is 0.03. We know that our, again, Z statistic is 1.96, and we know that big square root, we have 0.5 times 1 minus 0.5, and we are looking for N. So again, you can use your numerical solver on your calculator, so that way we don't have any calculation errors. Solve for N, again, you could easily type in X if needed. If you're not wanting to use your solver, you can divide by 1.96, square both sides, and then take 0.5 times 0.5 and divide it by your result. But I would use numerical solver. Type it in, comma, tell it to solve for N or X. And your results, you should get the calculator stating 1,068 people. And as a reminder, the only time you ever round up is for sample size, because we need that whole additional person. And that concludes confidence interval proportion.